January 17, 1944, Portsmouth Harbor, England. The air tasted of salt and diesel. Along the frozen docks of Portsmouth, where centuries of naval expeditions had begun and ended, a different kind of armada was assembling. Not warships, not troopships, but something far stranger, great drums of flexible steel pipe, each coil weighing nearly 3 tons. Stacked like the ribs of some mechanical leviathan waiting to be born. American corporals in oil-stained fatigues moved between them, their breath misting in the pre-dawn cold, checking manifests written in engineering shorthand that read like arcane prophecy. Pressure ratings, tensile strength, thermal expansion coefficients, numbers that would determine whether the Allied advance into Europe would surge forward or grind to a sputtering halt. Somewhere between the Norman hedgerows and the Rhine, they called it. PLUTO. Pipeline under the ocean. The acronym carried a deliberate absurdity, as if humor could disguise the audacity of what was being attempted. 70 miles of 3-inch pipe would be laid across the floor of the English Channel, the same waters where the Spanish Armada had shattered, where Napoleon's invasion barges had rotted at anchor, where Hitler's Operation Sea Lion had died before it could crawl from the planning table. Except this pipeline would not carry soldiers. It would carry something more essential to modern warfare than courage or steel. Petroleum. 24,000 gallons per hour. 1,000,000 gallons per day. Enough fuel to keep an entire mechanized army breathing as it tore through. Festing Europa. The corporals did not speak of destiny that morning. They spoke of gaskets and couplings, of the weight per fathom calculations that had consumed the previous 6 months. But in the careful precision of their work-in, the way they tested each weld, inspected each joint, there lived an understanding that transcended the technical. They were building a lifeline. And unlike the grand strategies debated in the war rooms of Whitehall and the Pentagon, this lifeline would either function perfectly or fail catastrophically. There would be no middle ground beneath the channel's cold currents, the problem had announced itself long before the first Allied soldier would wade ashore at Normandy. Modern warfare, the kind America had industrialized and perfected, consumed petroleum the way ancient armies consumed grain. A single Sherman tank burned 5 gallons per mile. A sortie of heavy bombers required thousands of gallons of aviation fuel. The supply trucks that would carry ammunition, rations, and reinforcements to the front each was itself a hungry mouth, demanding gasoline. British planners had calculated the requirement with grim precision to sustain Operation Overlord beyond the beachhead, beyond the breakout, into the race across France. The Allies would need to deliver fuel at a rate that exceeded the capacity of every port in England, even if those ports could somehow materialize on the French coast fully intact and operational, which they would not be. The Germans would demolish Cherbourg's facilities before surrendering the city. Le Havre would be rubble. Calais a wasteland. For months, perhaps longer, the invasion would depend on fuel delivered across open beaches through a temporary harbor called Mulberry, an engineering marvel in its own right, but vulnerable to weather, to U-boats, to the simple arithmetic of tonnage per tide. Jerrycans could be ferried ashore, yes. Tanker ships could anchor offshore and pump fuel through floating hoses, but the mathematics were unforgiving. At the projected rate of advance, with the planned concentration of armor and air support, the conventional methods would create a bottleneck that would slow Patton's Third Army to a crawl, that would ground the tactical fighters, that would transform the liberation of Europe into a grinding, fuel-starved stalemate, unless a pipeline could be laid across the channel floor, unless fuel could flow continuously, invisibly, beneath the reach of Luftwaffe bombers and Kriegsmarine torpedoes, unless American industrial genius and British engineering stubbornness could achieve what every expert consulted had initially dismissed as fantasy. The British Petroleum Warfare Department had conceived the idea in 1942, in those dark months when invasions seemed more hope than plan. But conception and execution were separated by an ocean of technical obstacles. Pipe that could flex without fracturing as it descended to depths of 300 feet. pumping stations powerful enough to overcome the hydraulic resistance of 70 miles of friction, a laying mechanism that could unreel pipeline from a floating drum at a speed matching the towing ship's advance, all while maintaining precise depth control to avoid both surface exposure and excessive bottom drag. And perhaps most daunting, the absolute requirement of secrecy. If German intelligence learned that a fuel pipeline was being constructed, if they identified its landing points on the Normandy coast, a single bombing raid or commando team could sever the Allies' petroleum jugular before the first gallon flowed. By late 1943, prototypes existed. British engineers had developed the core technology steel pipe wrapped in lead sheathing, then encased in a jutand tar coating that could resist corrosion and provide near-neutral buoyancy. Anglo-Iranian Oil Company had designed pumping equipment capable of generating the enormous pressures required. The Royal Navy had converted a merchant vessel, HMS Holdfast, into a pipe-laying ship. Her deck dominated by a massive drum around which the completed pipeline would be wound like thread on a spool. But the scale required the sheer industrial capacity to manufacture hundreds of miles of specialized pipe, to test it, to deploy it, to maintain it under combat conditions, seeded Britain's war-exhausted capabilities, which was where the American corporals entered the story. Not the generals who would later claim credit, not the admirals whose names would adorn official histories, but the enlisted men of the U.S. Army Corps of Engineers. Average age 23, most of whom had never seen an ocean until their troopships departed New York Harbor. Farm boys from Iowa who understood irrigation systems, factory workers from Detroit who knew assembly lines, roughnecks from Texas and Oklahoma who had sweated on oil derricks under a merciless sun, men who brought to the frozen docks of Portsmouth a characteristically American assumption that any engineering problem, no matter how novel or complex, could be solved through sufficient application of industrial horsepower, practical improvisation, and the kind of stubborn optimism that refused to acknowledge the word impossible. They had expected to build bridges, perhaps, or airfields, the glamorous engineering of invasion. Instead, they found themselves apprenticed to a project so classified that its very existence was buried, under false paperwork listing them as assigned to miscellaneous petroleum distribution duties. They worked in segmented teams, each group knowing only their specific task, the larger picture revealed to almost no one. Some assembled pumping stations in camouflaged warehouses, building redundant systems into every valve and motor, triple-checking pressure tolerances. Others tested pipeline sections in frigid water tanks, subjecting them to simulated channel conditions, cold, pressure, chemical exposure, the constant flexing that would occur as tides and currents worked the submerged line. Still, others trained on HMS Holdfast and her sister ships, learning the precise choreography of the laying operation, practicing until they could perform their roles in darkness, in storm, under the kind of pressure that would come when German coastal batteries were firing in the invasion. Timetable was measured in hours. What they discovered, in those months of preparation, was that the British gift for understatement masked a desperate gamble. The pipeline technology worked barely. It worked in test tanks and in short channel crossings attempted during calm weather. But no one knew whether it would work at the scale required. Under combat conditions, with hastily trained crews operating under fire, the calculations suggested it should function. The prototypes indicated it could function. But between theory and reality stretched 70 miles of hostile water, and the entire fuel supply for the liberation of Western Europe would depend on that untested span functioning perfectly from the moment it went. Operational, the corporals learned not to think about that burden. They focused instead on their small piece of the enormous puzzle. Seal this coupling. Test this pressure gauge. Inspect this weld for microscopic fractures. In the particularity of the task, the tangible reality of metal and rubber and flowing petroleum, they found shelter from the crushing weight of consequence. This was the American way of war. They were learning not the theatrical heroism of propaganda posters, but the quiet, methodical application of technical expertise to problems that would have paralyzed armies in earlier eras. The symbolic object that would come to represent PLUTO in the memories of those who built and operated it was not the pipe itself, it was the pressure gauge. Specifically, the burden tube pressure gauges installed at intervals along the entire system, brass-cased instruments with white faces and black numerals. Each one, a small, precise window into the invisible flow occurring within the steel arteries. The corporals learned to read those gauges the way a physician reads a pulse. Normal operating pressure was 1,500 pounds per square inch firm. Steady, indicating smooth flow across the channel. A sudden spike meant a blockage, perhaps a kink in the pipe or sediment accumulation at a low point. A gradual decline suggested a leak. Somewhere in those 70 miles of submerged line, hemorrhaging precious fuel into the cold water. A fluctuation, a rhythmic variation in pressure, could indicate pump malfunction, or far worse structural damage to the pipe from trawler anchors, mine cables, or deliberate sabotage. Those gauges became objects of near religious significance. Corporals would stand watch beside them for 12-hour shifts, recording readings every 15 minutes. Learning to detect deviations so subtle that the needle's movement was almost imperceptible, they developed an almost supernatural sensitivity to the system's condition. A gauge that read 1,487 psi was normal variance. A gauge that read 1,472 psi was a warning sign. A gauge that suddenly dropped to 1,350 psi meant an emergency team needed to be dispatched immediately because somewhere beneath the channel, the lifeline was failing. In those pressure readings, the corporals encountered a truth that would reshape their understanding of modern war. Heroism, they had been taught, meant charging machine gun nests or flying through flak-filled skies. But there was another kind of courage in standing watch beside a pressure gauge at 3 in the morning, exhausted, fighting sleep, knowing that a single missed reading could translate into tanks stalled for lack of fuel, into fighter planes grounded, into soldiers dying, because the logistics collapsed. This was unglamorous valor. No one would write songs about it. No medals would be awarded for it. Yet it was as essential to victory as any beachhead assault. The British engineers, who had conceived PLUTO, approached their work with a kind of grim irony, the dark humor of a nation that had endured 5 years of total war. But the American corporals brought something different, a matter-of-fact confidence rooted in industrial abundance. They had grown up in a nation where petroleum flowed as freely as water, where gasoline was cheap and plentiful, where the idea of fuel rationing seemed almost un-American. They understood, perhaps more intuitively than their British counterparts, that this pipeline was not merely an engineering achievement. It was an expression of national character, a physical manifestation of the industrial supremacy that would ultimately decide the war. Germany could produce brilliant tanks, fearsome submarines, devastating rockets. But Germany could not produce petroleum in the quantities required to fuel a mechanized military across a 1,000-mile front. That capacity belonged exclusively to the United States, and its ability to project that abundance across an ocean and under the channel would prove as decisive as any battlefield stratagem. June 6, 1944, while infantry divisions waded through the surf at Omaha and Utah beaches, while paratroopers descended into the Norman darkness, HMS Holdfast and her sister laying ships waited at anchor off the English coast, PLUTO would not be. Deployed on D-Day itself, the risk of damage during the initial assault was too great. The beaches too chaotic to secure the landing terminals. But within days, as the beachhead expanded and the fuel crisis began to manifest exactly as predicted, the laying operations commenced. The corporals who manned those operations experienced a strange inversion of combat. They worked under fire German. Coastal batteries still commanded portions of the channel, and Luftwaffe bombers occasionally broke through the Allied air superiority to strike at shipping. But their battle was against physics and engineering tolerances rather than human enemies. The laying ship would proceed at exactly 4 knots, no faster, no slower. Too fast and the pipe would snap under the tension. Too slow and the unreeling drum would overrun, creating slack that would kink and rupture the line. Meanwhile, the pipe descended through 300 feet of water. Invisible once it left the surface, its path traceable only through careful navigation and the deployment of marker buoys that had to be placed with surveyor's precision. Everything that could go wrong did go wrong at least once. Pipe sections fractured during deployment. Coupling failures occurred at depths that made repair nearly impossible. Storms disrupted laying operations, forcing ships to maintain position for days while gales hammered the channel. German intelligence eventually discovered the pipeline's existence, the secret. Despite all precautions, could not be maintained indefinitely, but by then, the laying was too far advanced to stop. The invasion's momentum, too overwhelming to reverse. What the corporals learned in those desperate weeks was that American industrial confidence had not been misplaced. When pipeline sections failed, replacement sections were already being manufactured in British factories, delivered to the coast, spliced into the system within days. When pumping stations faltered, backup units went online immediately. The redundant systems justifying every extra hour of design time. When German bombers managed to damage surface facilities, repair crews rebuilt them with a speed that suggested construction was simply another form of combat, one where Americans possessed overwhelming superiority. The first PLUTO line became operational in early August 1944. Just as Patton's Third Army was breaking out from the Normandy lodgment and beginning its spectacular dash across France. The timing was not coincidental. A dash hundreds of miles covered in weeks. German armies encircled and destroyed faster than Hitler's generals could redeploy reserves. It's possible only because fuel flowed continuously through the channel floor. While German panzer divisions stalled for lack of gasoline, their tanks abandoned by roadside or towed by horses, in scenes of industrial warfare reversed to medieval logistics. American armor raced forward on an uninterrupted stream of petroleum that seemed to the Germans who fought them almost supernatural in its abundance. Within months, multiple PLUTO lines were operational, not just the initial crossing from the Isle of Wight to Cherbourg, but additional lines from Dungeness to Boulogne as French ports were liberated. The system grew into a network, a petroleum circulatory system feeding the Allied advance with the kind of reliability that characterized American engineering at its finest. By war's end, PLUTO would deliver over 172 million gallons of fuel, enough to fill nearly 500 Olympic swimming pools. Enough to power the mechanized divisions that would smash through the Siegfried Line and drive to the Rhine. The corporals who maintained that system rarely saw the results of their labor. They stood watch beside their pressure gauges, recorded their readings, dispatched repair teams when anomalies appeared. Occasionally, reports would filter back from the Front Third Army advancing 80 miles in 48 hours. Fighter bombers, flying round-the-clock missions, supply trucks moving forward in endless convoys, and in those reports the corporals could trace the invisible connection. Their gauges reading 1,500 SOI meant those tanks had fuel, those fighters could fly, those trucks could roll. The pipeline, buried beneath the channel's waves, was as much a weapon as any rifle or artillery piece. More, perhaps because without it, all those rifles and guns would fall silent. German prisoners, interrogated after the war, spoke of the Allied fuel abundance with a mixture of bitterness and awe. They described watching American units waste. Gasoline, with what seemed criminal profligacy engines left idling for hours to power radios. Trucks driven a few hundred yards rather than walked, fuel used to burn trash or heat rations. 2 German soldiers who had pushed disabled vehicles by hand to conserve every liter of increasingly scarce benzene. Who had seen elite panzer divisions immobilized not by Allied firepower, but by empty fuel tanks. The American petroleum extravagance seemed almost obscene. It was, they realized too late, not waste, but a demonstration of industrial power so overwhelming that fuel could be treated as effectively infinite. That abundance had a psychological effect as devastating as any bombing campaign. German soldiers learned to recognize the American attack pattern, a brief, furious artillery barrage, then waves of armor and infantry advancing behind a moving curtain of fire, supported by tactical aircraft that seemed to appear within minutes of any request. All of it moving forward with a mechanical inevitability that suggested limitless resources. German commanders could plan brilliant defensive strategies, could position their forces with tactical genius. But they were fighting an enemy who could simply sustain operations longer, move faster, replace losses more quickly. The Blitzkrieg had been Germany's gift to modern warfare, the lightning war of rapid mechanized advance. But PLUTO and the logistics system it enabled allowed America to conduct a kind of sustained lightning war, continuous blitzkrieg that never paused for fuel or supplies, that just kept coming until German resistance collapsed from exhaustion. The corporals who operated PLUTO were only dimly aware of this strategic impact. They knew their pipeline was important. They understood that fuel was critical. But the connection between their pressure gauges and the collapse of the Wehrmacht's fighting capacity in the West remained abstract, something glimpsed only in retrospect. What they experienced directly was the transformation of their own understanding of what winning a war required. They had enlisted, most of them with visions derived from previous wars, from stories of individual heroism and dramatic battles. What they discovered instead was that modern warfare was won or lost in maintenance logs and supply manifests, in the unglamorous work of keeping complex systems operational under adverse conditions. The Sherman tanks that liberated Paris were heroic symbols, but those tanks existed at the end of a logistics chain that stretched back across the Atlantic, through the English ports under the Channel via PLUTO, and forward through an intricate network of supply depots and fuel dumps. Break any link in that chain, and the tanks became immobile steel coffins. Maintain every link, and they became instruments of liberation. This was the peculiar genius of American military power, not necessarily superior tactics or strategy, not always better weapons or braver soldiers, but an almost neurotic obsession with logistics, with the unglamorous back-end systems that kept armies fed, fueled, and fighting. The corporals of PLUTO were disciples of that gospel, though they might not have articulated it in such terms. They simply did their jobs, watched their gauges, maintained their equipment, and trusted that somewhere far from the Channel coast, their work mattered. The symbolic pressure gauge acquired over time an almost talismanic quality. Corporals who completed their service and returned home often spoke of those gauges with more emotion than they reserved for any battle narrative. The gauge represented certainty in an uncertain environment, tangible evidence that the system was functioning, that their work had meaning. In later years, when asked about their war service, they would describe not the fear or excitement of working near combat zones, but the satisfaction of a steady pressure reading, the relief of a system functioning as designed. One corporal, writing decades after the war, described a moment in late 1944 when he stood watch during a Channel storm. The laying ships had been forced to suspend operations. The existing pipeline was being hammered by waves and currents. Every engineer had predicted catastrophic failure. The pipe would snap, the coating would rupture, seawater would flood the line, and the entire system would require months to repair. He stood beside his gauge, watching the needle, waiting for the pressure drop that would signal disaster, and the needle held steady. 1,498 psi, 1,502 psi. Minor fluctuations within normal variance. The pipeline, flexing under 300 feet of storm-churned water, was holding. The fuel was still flowing. Somewhere in France, tanks were being refilled. Fighters were being armed and fueled. Trucks were rolling forward. Because the pipeline held. That moment, he wrote, taught him something about American power that no propaganda film or patriotic speech had captured. It was not flashy. It was not theatrical. It was simply relentless, methodical, competent. It was the power of systems that worked, of logistics that functioned, of industrial capacity so vast that it could afford redundancy and over-engineering and safety margins that seemed excessive until they became the difference between success and failure. The Germans had designed beautiful weapons, the Panther tank, the Me-262 jet, the Type 21 U-boat. But Germany had not designed a fuel pipeline under the English Channel. That required a particular mindset, a belief that engineering could solve problems that seemed insoluble. That quantity had a quality all its own. The victory came not from brilliant strokes, but from 10,000 small competencies executed reliably. May 8, 1945, the war in Europe ended. Pluto continued operating. Even in victory, the fuel demands remained enormous. Occupation armies to be supplied, displaced persons to be fed and transported. The massive logistics of demobilization and reconstruction, the pipeline that had been built to sustain an invasion now sustained a peace. Its original purpose fulfilled, but its utility undimmed. The corporals who had built and maintained it began the long journey home. Most returned to unremarkable lives: construction jobs, factory work, college on the GI Bill. Few ever discussed their war service in detail. Pluto remained classified for years after the war's end. The British government reluctant to reveal the technical details that had been so closely guarded. The corporals had signed secrecy oaths, and they honored them, even when doing so meant allowing neighbors and relatives to assume they had spent the war in some support role far from combat, but among themselves. In the occasional reunions and correspondence that aging veterans maintain, they spoke of the pressure gauges, of the satisfaction of a steady reading, of the moment when the first Pluto line went operational and fuel began flowing, and everyone involved understood that something historically significant had been achieved. Even if the world would not learn the details for decades, they had laid a pipeline under the ocean. They had defied expert skepticism and technical obstacles and enemy action. They had done so not through individual heroism, but through collective competence. Through the patient application of engineering principles and the willingness to execute unglamorous work with absolute precision. In the history of World War II, Pluto occupies a footnote. The landing at Normandy is remembered, the breakout from the bocage, the liberation of Paris, the race to the Rhine. The battles have names and dates, heroes and narratives. But the pipeline beneath the channel, the unglamorous lifeline that made those dramatic advances possible, remains largely unknown outside specialist histories. Perhaps that is appropriate. The corporals who built it were not seeking glory. They were solving a problem, executing a mission, fulfilling a role that required technical skill rather than martial valor. Yet there is a deeper truth in Pluto's obscurity. The pipeline represented a kind of power that democracies wield most effectively, not the power of domination or conquest, but the power of organization, of logistics, of the patient construction of systems that enable freedom's advance. Totalitarian states could inspire fanaticism, could drive their populations to extraordinary sacrifices, could achieve stunning tactical victories through ruthless efficiency. But they could not match the sustained, methodical application of industrial and technical capacity that characterized the American war effort. They could not build a pipeline under the English Channel. Not because they lacked the engineering knowledge, but because such a project required trusting thousands of individual workers, corporals, and privates, welders and mechanics to execute their roles competently without constant surveillance and coercion. The pressure gauge then became more than a technical instrument. It became a symbol of that trust, of a system that functioned because each component, human and mechanical, performed reliably. When the gauge read 1,500 psi, it meant the pumps were working. The pipe was intact, the fuel was flowing, but it also meant thousands of individual decisions had been made correctly. An inspector catching a faulty weld, a maintenance crew performing preventive service, a watchstander noting a subtle pressure variation before it became a catastrophic failure. The steady pressure reading was evidence of collective competence, of an organizational culture that valued precision and reliability over theatrical gestures. In this, Pluto captured something essential about the American way of war, and perhaps about American democracy itself. It was not perfect. The system experienced failures and near disasters throughout its operational life, but it was resilient, adaptable, and ultimately effective. When problems arose, they were solved through ingenuity and improvisation rather than rigid adherence to doctrine. When components failed, redundant systems maintained operation. When the original design proved inadequate, it was modified and improved. The pipeline was not a work of genius in the way that term is usually understood. No single brilliant insight made it possible. Instead, it was a work of engineering humility. acknowledgement that complex systems require patient development, thorough testing, and the willingness to learn from failure. The corporals of PLUTO returned home with this understanding, though they rarely articulated it explicitly. They had learned that democracy's strength lay not in producing supermen or wonder weapons, but in enabling ordinary people to perform extraordinary tasks through organization and mutual support. They had seen how abundance, the seemingly limitless supply of materials, fuel, spare parts translated into strategic advantage. They had experienced the transformation from civilians into specialists, had discovered within themselves capabilities they had not known they possessed, and they had watched pressure gauges. Those simple instruments, monitoring invisible flows through hidden pipes, became the measure of success, the tangible proof that vision could become reality. When veterans of PLUTO encountered the post-war world, the interstate highway system, the commercial jet aviation, the petrochemical industry that would define the American century, they recognized the same principles at work. Complex systems, carefully engineered, reliable infrastructure maintained through patient effort, abundance as a strategic choice, a decision to invest in capacity that seemed excessive until crisis revealed it as essential. The pipeline beneath the channel operated until the European petroleum distribution network was rebuilt through conventional means. Then it was shut down, the pipe left in place on the seafloor, too expensive and dangerous to recover. It remains there still, buried under decades of silt and current. A submerged monument to an engineering achievement that few remember and fewer understand. Sometimes, fishing trawlers snag their nets on it, puzzled by the obstruction that appears on no charts. Occasionally, recreational divers encounter it, a rust-encrusted pipe emerging from the sediment, its purpose mysterious, its story unknown, but for those who built it, who maintained it, who stood watch beside those pressure gauges through long nights and longer weeks. PLUTO represents something more enduring than steel and petroleum. It represents the moment when industrial democracy proved its capacity to project power, not just through destruction, but through construction. Not just by defeating enemies, but by solving the logistical puzzles that made sustained operations possible. The corporals who wound pipe onto drums in frozen British harbors, who monitored pressure readings off the Norman coast, who repaired leaks and replaced pumps, and kept the fuel flowing. They were as essential to victory as any soldier who carried a rifle ashore at Omaha Beach. More essential, perhaps because without them, those soldiers would have advanced only until their fuel ran out, only until the logistics chain snapped, only until the reality of modern warfare reasserted itself. In the end, PLUTO was not merely a pipeline. It was a promise, fulfilled the promise that American industrial might, organized and applied with technical precision, could overcome obstacles that seemed insurmountable. That promise sustained the Allied advance across Europe. It fueled liberation. It demonstrated to friend and foe alike that the United States possessed not just military power, but the deeper, more durable power of systematic competence. The pressure gauges are silent now. The pumps no longer run. The fuel no longer flows through those submerged pipes. But the principle they represented, that democracy's strength lies in the patient construction of reliable systems, in the collective effort of thousands performing unglamorous tasks with precision and dedication, that principle endures. It was proved beneath the English Channel in 1944 by corporals who never sought fame and seldom received recognition, but who built a lifeline that helped free a continent, and that truth, like the pipeline itself, lies deeper than the surface chaos of war, permanent and foundational, a buried artery through which victory flowed.